why do we need the product rule when we differentiate a product? Okay? The reason why is because when we think of a product, the product is actually the area of a length times width. So when we talk about the product of two functions, we can think of one of the products or one of the factors as a length, the other factor as a width. And really what we're asking then is the change in u times v is really, we're asking, how does the area change? How does the area change when we increase the length and width? Okay, so basically we want to see what are the pieces that cause the change in the area. So when we look at this again, here's my original area in red. It's my length and width. So there's my v of x, there's my u of x. And what we want to know then is, as I change the area, okay, as I change x, how does the area change? Well, the area is going to change with this green area here, this yellow area here, and this blue area here. So that's the change. That represents the change in the area. Okay, and that's my derivative, is a change. So the change in area is going to be this, this, and this. Well, how do I express that change? Well, the change in this piece here, the green area, is represented by this length, u of x, okay, times the change in the v, or the dv. So this is u of x times the derivative, or change in v. So this length times the change in v gives me the green area. Well, how about the blue area? The blue area is going to have this width of v, and it has a length of du. So this change in area is going to be represented by the v function times the change in the u function, or the derivative of the u function. There's also this extra area here, this is in the top right hand corner, but these areas, this dv and du, or remember, they're infinitesimally small. So really this is actually a really thin strip. This is a really thin strip of rectangle. This is going to be just a tiny insignificant bit of area. So the dv times du we treat as insignificant. So algebraically it starts to look like this. Okay? So we end up with, as x changes, the area changes with the green and the blue and the yellow. Okay? And the sum of the areas of those changes, okay, here's my green area, here's my blue area, and this is my yellow area. Okay? And this yellow area tends to be, we can essentially say, because it is a very small change in v and a very small change in u, we're just going to say that's essentially insignificant, and we're left with this function here, this u times dv, v times u, which is our product rule. Now we can finish this up algebraically. You notice that there's a dx missing. Well, we just divide all this by dx and we come up with the product rule.